Okay, so this is 2.4a in college algebra, solutions of linear inequalities. And if you remember inequalities, they're the greater than, less than, greater than or equal, less than or equal. They also include the not less than and not greater than, but we don't really get into those much. So anyway, let's look at the section preview there for a minute, because it's always good to be reminded of the revenue and the weekly cost. So they're saying that the weekly revenue is 400 times X, meaning the number of items you sold, and the weekly cost would be 200X plus 16,000. Okay, and that weekly cost is the amount of setup to get ready to sell this product, the cost of materials and labor, times how many you sell. Okay, so what we're looking for is profit. Now our profit, in order for that to happen, our revenue, the amount we sell, has to be greater than the cost. If it's not greater than the cost, we have not made a profit. We said that that is our revenue. So 400x, we're just going to replace r of x with 400x, and we're going to replace the c of x with this. And notice by replacing or substituting, we have one variable, and that being the x value there. So we can take this and solve it because we have one equation, one variable. So an inequality is a statement that one quantity or expression is greater than the other one, or less than the other one, or greater than or equal to, or less than or equal to. Those four are the ones that we're looking at. Linear equalities on the bottom of page 139, or first degree inequality in the variable. X is an inequality that can be written in the form ax plus b is greater than 0, where a is not equal to 0. And they have the form here. And let me just remind you, when we're dealing with x's and y's and z's, which we'll get into later, those are variables. The A and the B and the C, the first few letters of the alphabet, are representative of coefficients, numbers in front of the x, or just numbers all by themselves, a constant, that one that does not vary depending on anything. These are called variables because the value of x varies depending on things. These are constants because they do not change. All right, so just a little bit of information there to help you remember that. Okay, so top of page 140, the inequality 4x plus 3 is less than 7x minus 6. That is a linear inequality, or what they call a first degree inequality, because the highest power of the variable is a 1. Remember, if there's nothing up there, it's an assumed 1 right there. And it's a first degree inequality because the highest power of the variable is a 1. The values of x that satisfy the inequality form the solution set. For these problems, you're going to get sometimes just one or two answers, but usually you're going to get an infinite number of answers. For example, if I said x is less than 2, how many answers are there? Well, there are an infinite number of answers. All of the numbers that are less than 2 will make this a true statement. So that's what I'm saying is an infinite number of answers. Okay? So, solving an inequality means finding all of the numbers that make the statement a true statement. So all the numbers that make that a true statement. The solution to an inequality can be written as an inequality or in interval notation. All right, this is written as an inequality right here. If I wanted to write this in interval notation, I would write it as negative infinity to like that. And remember, the little curved means that it does not include the number next to it. So it does not include 2. If this were a less than or equal to sign, then this would be a squared off, meaning that it does include 2 in your answer. So interval notation and inequality. All right, the solution can also be represented by a graph on a number line, and if 2 inequalities are equivalent, if they have the same solution, then they're equivalent. All right, so the steps to solve a linear equality are the same as those to solve a linear equation. Okay, so we're going to be just doing a little bit of practice here. You've done these before in your many years of math, and so hopefully this won't be too painful as we go through example 1. 3x minus 1/3 is less than or equal to -4 plus x. And I do need to tell you, I've always hated inequalities. I have no idea why, but I just have always hated them. So if you hate them, then you can be in my club. All right, so first thing we're going to do is we're going to get rid of the fraction. I hate fractions, so let's just get rid of it by multiplying the entire thing by 3. Okay, so it'd be 9x minus 1 is less than or equal to -12 plus 3x. Okay, so we got rid of the fraction, and that made life a little bit easier. So what we're going to do is we're going to solve for x here. So we're going to subtract 3x from both sides. You're going to add 1. I'm just kind of doing multiple steps here. And -11, so that gives me 9 minus 3 is 6. X is less than or equal to -11. Divide by 6, divide by 6. X is less than or equal to -11 over 6. So if I wanted to graph this on a number line, and I make that a 0, make this -11 over 6, and my solution set is going to include, let's do it in blue, 11 over 6. So I block it off like that, and I draw this because it's less than -11 over 6. Okay, if I want to write this in interval notation, negative or infinities always get the rounded. -11 over 6, because it includes it, gets the boxed off version. And there's my answer. So I've got inequality, interval notation, graphing. All there is an option as far as how to write this. Okay, one of the things that some of you, I'm sure, are wondering at this point, because you go way back into your math career and you're like, now wait a minute. This thing is supposed to move direction at different times, right? It's supposed to flip around. Why didn't it flip around? Okay, the reason it flips around is if you are dividing by a negative number. So if I'm trying to get rid of this -3 here, I'm going to divide both sides by -3. And because I divided both sides by -3, then my sign flips over. A lot of people will say it follows the negative sign. Okay? So if both sides are multiplied or divided by a negative number, the sign will flip. Okay? But that's the only time. So I'm not going to actually do example 2, but I will at least kind of go over it a little bit. This is from earlier. We talked about Rx is this and C of x is this, and we want to know for this electronic reading device, probably like a Kindle, our revenue is 400 times whatever number we sell, and our weekly cost is how many we sell times 200 plus 16,000, which is probably setup fees and advertising and stuff to get things going. So when our revenue is higher than our weekly cost, then we make profit. So at that point where these two are equal, anything after that is going to be profit. So what we're trying to do is, when is revenue greater than cost? So that's what they did. Instead of Rx and C of X, they use 400X is greater than 200X plus 16,000X. Solve for X. X is 80. So when we sell 80 of these boogers, that's the place where we are making a profit. Okay? So 80 of these, this and this, are going to be equal to each other. So if we sell more than 80, 81, then we're going to be making profit. Okay, so that's what that does there. All right, so let's look at example 3. Basically the same thing. Child's health is at risk when the temperature is above 103 degrees Fahrenheit. Above 103. Okay. What Celsius temperature reading would indicate that a child's health was at risk? So what we're trying to do is find out what this is in Celsius, because anything above that in Celsius would be dangerous for a kid. So here is the formula. Fahrenheit equals 9 over 5 C plus 32, where F is the temperature in Fahrenheit, C is the temperature in degrees. Sorry, I'm talking so fast. So instead of using F, where F is greater, Fahrenheit is greater than 103, we're going to use the crossover. Instead of this, we're going to use this formula. So we're going to say, when is this higher than 103, or equal to, greater than or equal to, because it says temperature is 103 or higher. So what we're going to do is we're going to use this formula instead of F for Fahrenheit, and we're going to find out when that number is greater than 103. At what point is Celsius equal to or greater than 103? So they solve for Celsius, and they find out that Celsius is equal to 39.444 all into infinity. So when Celsius temperature is greater than or equal to 39.444, repeat, at that point, that is when it's dangerous for a kid, because 39.44 is 103 degrees Fahrenheit. Okay, takes us to the next section, which I will call 2.4B as in Bravo. So be looking for the next video, and we will continue with graphical solution of linear inequalities.